Chips are down. Zscaler zeroes in on AI. It's time for retimers. Low power optics. Copilot gets a new pilot. Selector aims for AI. And we're going to talk all about the announcements from NVIDIA GTC in this episode of the Gestalt IT Rundown. Hello, everyone, and welcome to the March 20th episode of the Gestalt IT Rundown. I know that you're feeling something like happiness today, because it is National Happiness Day, but I know exactly why. Because it's also National Data Center Day, and I know that makes everyone in the world out there very happy, including my wonderful co-host, Mr. Stephen Foskett. Stephen, are you feeling some data center happiness today?
I am feeling data center happiness. I'd also like to point out that it is National Macaron Day, which makes me always think of the president of France, but it's actually like this styrofoam cookie that usually tastes terrible, but tastes exquisite and sublime in France. Don't try them in America.
Exactly. And also not to be confused with macaroons, which are little coconut cookies, which are much, much worse. You want to avoid those. You want to stick around for all of the great news that we have coming up today, because there is a packed schedule of things that we want to talk about. We want to start off with a new announcement coming from the U.S. Commerce Department, because they announced a $19.5 billion funding package for our friends over at Intel to support chip manufacturing in Oregon, Arizona, Ohio, and New Mexico. With a focus on advanced manufacturing, chip packaging, and high-risk research and development, this initiative leverages loans and tax credits, as well as a cool $8.5 billion in grants. Now, we have been talking about the CHIPS Act for quite a while here. We've also talked about Intel's manufacturing investments. So, Stephen, what is new about this news here?
Yeah, I think that's worth asking, and it's confusing. I mean, federal, government funding is always confusing. But as you said, we are focused on the Intel angle and the angle for enterprise tech. One of the things that I've been harping on for like a year here was that so much of the CHIPS Act funding was going for production of semiconductors, basically, etching wafers, and yet where are these things going to be packaged? They're going to be shipped to Asia for packaging in the advanced packaging plants in places like South Korea, Taiwan, and Japan, and now emerging in places like Vietnam and Malaysia. Well, guess what? Intel understands this, no surprise, and they are also going to be investing in packaging here in the US, including their new 3D packaging, which, thank you, that's great, that's awesome. They're also committed to bringing their most advanced manufacturing to Chandler, the Arizona plant, which is going to be 18A. Again, great news for everybody. They're going to be looking at, of course, funding the Ohio plant here in Ohio, as well as supporting advanced R&D. And I think that's the most interesting angle here. So forget the funding, forget the dollars and the federal government, and even some election year politics of all this. One of the most interesting angles here is that Intel is basically committing to try to leverage basically high NA lensing in order to create next generation process nodes. So here's the thing. Basically, we've gotten to the point where we are producing as fine tiny features on our chips as we can with EUV, which is the current light source used for etching these wafers. TSMC has, and Intel and Samsung and the rest have a fork in the road here. They have to decide whether they're going to invest in trying to come up with shorter wavelength systems, which basically means throwing everything out and rebuilding everything, or trying to make the current stuff go a little bit further, which is what TSMC is trying to do, or looking at higher numerical aperture lensing. Now, lensing, this is a kind of a big bet. It's not obvious that it's going to pay off. You need to have a lot of new things, new masks, smaller imaging fields, all sorts of things in order to make this work. And Intel is going to use some of this money, some of these billions of dollars, to try that. And that is a big deal. That is a big deal because theoretically, if this works, and I'm sure that the manufacturer ASML who makes these systems is confident that it will work. If it works, if Intel can pull this off, they will jump ahead of TSMC on process nodes, almost certainly. And we will be in a new world where the most advanced chips are built by Intel and Intel factories. If it doesn't work, well, goodbye to those billions, goodbye to that time, and then Intel's going to have some catching up to do. But that being said, it's exciting to see that they are going to be trying to push forward with a new technology. And as I mentioned, that they're going to be investing in these fabs and investing critically in packaging so that they can bring these chips to market. One more thing, of course, is there was some news about Pentagon funding. This doesn't resolve that. There's still concern whether the Pentagon is going to support Intel and having a secure chip manufacturing system, and we don't know the answer to that yet. It's likely that there's going to be more money coming out. If I was an investing man, I would say that this is good news for Intel, but so far it seems like Wall Street doesn't agree, so we'll find out. Zscaler is expanding their security offerings that include AI by acquiring startup Avalor Security. The deal is reported to be worth about $310 million in cash and equity. Avalor's main offering acts as a source of truth for security assets. The goal is to use Avalor Data Fabric for security to augment their zero trust platform with integrations that Avalor provides out of the box. Tom, you're very familiar with the security market generally and Zscaler specifically. What do you make of this?
So I think this is a great pickup by Zscaler because what they're effectively doing is they're creating a source of truth to run all of their AI off of. We know AI requires data. We've known that for a very long time, but we also know that the quality of that data matters significantly. If you start running your LLM against a flawed data set, what you're going to get back is flawed results and flawed suggestions. You have to make sure that the data is consistent. And that's what Avalor is allowing Zscaler to really start with. They have around 150 integrations that allow them to pull data in from a variety of sources and kind of verify it. And that is so critical. And I don't just mean that in the security space. If you look back on some of the things that I've written on gestaltit.com about source of truth, it's very critical for network configuration and stat as well, because if you don't have all of that information, you're just kind of flying blind. So what Zscaler is saying is we can run AI and machine learning models against all of this data and come up with a great way to create zero trust boundaries that allow your people to effectively do their jobs, but also to kind of, dynamically adjust on the fly to address new threats and stuff like that. All we need is good quality data. Well, for $310 million, I think that Avalor is a huge bargain, for lack of a better term, because the amount of data that they can collect and can centralize and then allow Zscaler to really kind of add those AI functionalities into some of their packages and licensing models, they're going to make this money back in a heartbeat, really. And being able to do this dynamically in real time, according to the press release from Zscaler, is really going to help out folks as well, because one of the things that we've seen over the last, couple of years is the way that these threats can dynamically change and escalate in a matter of minutes. So getting real-time updates and being able to create these policies and get people, engaged and active in it, I think is super critical. So I think this is going to be a good win for Zscaler, and I can't wait to see when it gets rolled out into their main product line. I would expect it's going to happen within a matter of months, because we know that people out there are hungry to deploy these solutions and make sure that they can reduce those risk factors for a lot of their, users. The market for specialized server components is seeing a little bit of heated competition this week. If you don't know, retimers are a huge part of the PCIe spec. It allows for signal boosting for electrical impulses that span larger distances and longer times in larger areas and things like that. It's critical in the AI market because the footprint of these systems is massively growing beyond just a simple 1U or 2U server. Broadcom started the race in this retimer competition by releasing their latest Vantage lineup, which includes PCIe Gen 5 and Gen 6, as well as CXL retimers. And then the next week, Astera Labs announced that they were going to be filing a huge IPO valued at nearly $4.5 billion. And then they announced their own lineup of PCIe Gen 6 retimers. I know that retimers don't sound like the most exciting technology out there, but I know that they're super critical for the way that these AI systems operate. Stephen, could you give us a little bit more background on why this is going to be such a big deal?
Well, retimers are critical, as you said, simply because you need them in order to deliver more and more performance on PCI Express. So, just for a sense of scale, the maximum distance that a PCIe signal can travel is shrinking as the performance gets higher because simply there's more data going over it over a shorter period of time, and they have to make sure that everything is correct. I mean, PCIe is one of those protocols that really requires absolute signal integrity. For scale here, a PCIe 5 signal can only travel, no kidding, about 4 inches without a retimer. Now, 4 inches is enough to basically go from a CPU to an expansion card that's on a motherboard pretty close. But it's not a lot when you're talking about a big server that can be, 19 inches wide, 23 more inches deep. You're starting to need retimers all over the place. And if you look in a modern server, there are a bunch of retimers in there. Astera has really done a nice job of delivering compelling PCIe 5 retimers, and they've got, I don't want to say they cornered the market, but they've got a really nice chunk of the market in the retimer market now in modern PCIe 5 systems. Broadcom came out, as you said, and announced their own PCIe 5 and 6 retimers. And now Astera is here saying, no, we got that covered. We've got a PCIe 6 retimer. It's already sampling, and it uses less power than the new one Broadcom just announced. So Astera has a pretty great story here. So great that their IPO has already been priced up. I guess the latest breaking news is that they've priced their IPO at $36 a share, which was higher than the original range, which was said to be maybe 27. What that means is Astera is pretty confident that they've got a compelling solution that's going to beat Broadcom in this market. And, from the outside looking in, I would say it does too. Now, this is, arguing over a little tiny chip, but these little tiny chips are everywhere. And as we're going to talk about in a little bit here, the latest announcements coming out of NVIDIA GTC show just how important it is, the minute differences in connectivity, in power, in signal rate and data rate. That makes a huge difference to basically everything in the data center. Astera is right in the middle of that, and frankly, looks pretty good, pretty well positioned here in the market. Broadcom announced the new Bally Ethernet switch this week. The big new feature for the platform is co-packaged optics. This new process of creating switch connections consumes 70% less power while providing a huge increase in efficiency. The total throughput of the Bally switch is 51.2 terabits per second, and it's based on the Tomahawk 5 silicon. This unit has a maximum of 128 ports of 400 gigabit Ethernet. Dr. Nir Margalit stated that the pluggable optics accounted for almost 50% of the power consumption of the switch, which necessitated the design choice to have co-packaged optic design. Now, this sounds like pretty niggling stuff, Tom. Give us some perspective on co-packaged optics and the market for these new high-performance Ethernet switches.
Any traditional Ethernet switch that you've been using basically since the beginning of time, if it has a module that plugs into it that has maybe a fiber connection that plugs into it, all of the intelligence for kind of how that system works is contained in that module. That's why, like, I remember when the first 100 gig Ethernet pluggable module came out, it literally was the size of like an iPhone 4. I remember looking at it whenever the whole router had to be dedicated to running that one optic. And granted, this was back in like 2010, 2011. And as we've grown going forward, one of the things that we have seen is that power consumption of these modules goes up a lot because they have to build more intelligence into them. And I'll tell you a little secret. Power is power no matter where you get it and how you do it. But that power, because it is measured in watts, also translates into another waste product called heat. And if you can imagine a switch drawing hundreds of watts, if not thousands of watts of power through these optical modules, that thing gets really, really hot. Years ago, we had a great conversation with Andy Bechtolsheim at Arista, and he basically said one of the limitations that we're going to see as we start increasing the speeds of Ethernet is not going to be throughput, it's going to be heat, because we can't keep the switches cool. And this is a direct result of creating co-packaged optics. So basically what you're doing with the system is, instead of putting the brains in the pluggable module, you are now putting the brains onto the chip itself, where it can be soldered together, where you can have less travel distance, like we just talked about in the last story, of how far these signals can go. Well, now they're packaged directly onto the system itself, and all you have is a little module that has a fiber line in it, and you plug it into the port, and that lights it up. Well, according to our friend over at Broadcom, who's quoted in the story, like, that reduced the power consumption of the switch by 50%. Like, that's a massive increase in not only efficiency, but a reduction in heat. Because now, like, I don't know if you've ever been next to a switch that has all connected with fiber. Those things like hum. You could probably roast a marshmallow up against them. This means that, one, if Broadcom or any other company that uses co-packaged optics chooses to shrink the footprints of these switches, they can do it now without having to like bolt a gigantic fan on top of it to pull the heat off. Or it means that they can create much larger switches with much higher densities and know that they can keep those switches cool. It also reduces a lot of the extra complexity, because you no longer have to worry about how these modules work. Look at something like a QSFP or an OSFP. There's only so much that we can do with that specific kind of form factor. So like a QSFP is just like what it sounds. It's a 100 gig port with 4 modules to make it a 400 gig port. So you basically have like this weird cable that has to plug into it. And an OSFP is an octo SFP. So it has 8 of those. So it's like a little octopus trying to crawl in the front of your switch. I think that this is a great leap forward in the technology. And quite honestly, I think that for any speeds north of 400 gigabits per second, which is what Bailey's default is, I think we're going to see co-packaged optics, whether it's 400, 800, or into the terabit Ethernet range, because the amount of heat generated otherwise is not going to be suitable for how these switches are going to need to operate, especially in a data center, unless your data center is filled with liquid nitrogen and basically is in Nome, Alaska. That's the only way that I can think of it. It'll work. And since nobody wants to move all their data centers to the north of Alaska, I think co-packaged optics are the way to go. Microsoft has a new pilot for Copilot. Mustafa Suleyman will be joining the company and creating a new business unit called Microsoft AI, which is focused on developing Copilot as well as their consumer-focused AI solutions. Suleyman was the co-founder of DeepMind and was most recently at Inflection AI, which was a rival to Microsoft-backed OpenAI. Most of Suleyman's staff will be joining him in the move, including the chief scientist for Inflection. The existing Copilot team will report to Mustafa going forward, and the move is seen as a way for Microsoft to keep their lead in the AI space against companies like Google, who will be trying to carve out their own niche for this huge market. Stephen, you've been following this very closely, and as the host of Utilizing AI, you have a lot of insight into this. What kind of a move is Microsoft trying to make here?
Well, I'd say first off, this is a really interesting angle corporate-wise. So it's important to note that Inflection AI appears, at least from the press release, to be continuing its work, even though basically all of the employees are going to be Microsoft employees now. I suspect that probably Inflection AI is going to be continuing as a Microsoft project, but this doesn't appear to be an acquisition of the company. I just don't understand what is going on here from a financial perspective, but hey, I'm not a financial analyst. What do I know? But let's talk a little bit here about Mustafa Suleyman and Karen Samanyan and the rest of the folks over at Inflection AI. So as you mentioned, they were considered to be a competitor for OpenAI. They were also rumored to be one of the biggest customers of CoreWeave, which is the AI specialist infrastructure as a service provider that basically has a lot of NVIDIA GPU technology. So this is a really interesting move that could really upset the whole apple cart in terms of who's developing what and where and who's running what on what and all sorts of things. I mean, this almost certainly would mean that the next generation work from this team would be running on Microsoft's hardware. which, although it may come from NVIDIA or it may not, wouldn't probably be CoreWeave. It also means that Microsoft has acquired a team with a really great track record of producing pretty impressive AI. DeepMind was acquired by Google about 10 years ago. Suleyman worked there for quite a while, leading a lot of their AI efforts. There's some stuff about his leaving that was a little concerning about management style and so on. But essentially, by all accounts, this is somebody who really understands not just AI generally, but specifically what it needs to go to the next level. One other thing that I'll mention is a recent book that everybody's talking about, The Coming Wave, which is about the dangers of both AI and synthetic biology. Well, that was written by Suleyman and researcher Michael Bhaskar. And this is getting tons and tons of traction, especially in technology circles, where people are getting very concerned about basically where all this is headed. The fact that the guy who wrote that book is now going to be heading Copilot at Microsoft actually, I think, is good news, because it means that we've got leaders at some of these companies who truly understand the impact and the challenges, the dangers of what they're building. So overall, I would say that this is probably a real strong positive for Microsoft. Once again, Satya Nadella is playing chess better than almost everybody else in the industry. I would say that this is probably going to upset some of the expectations for next generation AI in terms of the challenges to OpenAI, the market for CoreWeave, things like that. But overall, for end users, I think what this means is that we're just going to see a lot better AI coming from Microsoft thanks to this team from Inflection AI. Selector AI has released their newest update for spring 2024. Included are a host of new tools to help accelerate AIOps for teams that want to leverage Gen AI advances. There's a new Copilot tool to help summarize incidents and automate remediation. There's also a new capability for directly collecting configuration and metric data on the platform to help provide feedback and aid in troubleshooting. Selector also has the capability to create a digital twin of target infrastructure for testing and evaluation, which is something that we've been hearing about quite a lot at our field day events. Tom, what's your assessment of Selector AI's spring release?
I think this is huge. I mean, we did get to see a peek at some of the capabilities that they came out with back at Networking Field Day 30, and to see how it's grown since then. I think that they are really kind of following the lead of the market here. I mean, the Copilot tool is kind of one of those almost at this point table stakes things that you really have to have. But with Selector's capabilities, I think it is a massive win for their customers, because it will allow you to, kind of go in, do case summaries, understand what's going on in your network, get troubleshooting advice, even, here's what you need to type in to make this thing happen. Note that is suggesting what you're going to type in, not actually doing it for you, because there's still a lot of people who aren't comfortable with that. That's why it's Copilot, not autopilot. I think the other thing too is this idea behind digital twins. That's something we've seen from several companies in the market that are kind of collecting all of this data and then giving you a model to, kind of play around with, for lack of a better term. But more importantly, it's something that you can test, assure that yourself that you're not going to break things when all of this stuff kind of comes out of the wash, and then actually make it happen. So for those of you out there who are still not 100% certain if you trust an LLM or some kind of natural language model to give you ideas for how to fix a problem, that's what a digital twin does. So take that suggestion, plug it into the digital twin, and then see if it breaks anything. Odds are good that it won't, because a digital twin really is a representative of your network. As we heard at a recent event, a digital twin is something you use every day if you drive in a car, because using GPS is a digital twin of your physical environment. And that's basically where you can try to, do different routes through GPS. That's what implementing these solutions in a digital twin of your network allow you to do. Well, what if I do this? Oh, well, that caused this routing table to fall over. Well, what if I did this? Oh, well, that actually seems to work really well. So rather than doing that, let's tweak this solution. These are the kinds of things that customers really want from these products. It's not just a massive tidal wave of data that you have to read through and kind of understand. It's more about getting to the quickest solution to solve the specific problem that you have, and then having a way to make sure that any other implementations that we do aren't going to cause problems in the future. Let's be honest, if you're one of those companies that doesn't have a change control process right now, digital twins are the way to go. So I would definitely recommend checking them out. And I do want to mention that Selector AI is going to be a part of an upcoming networking field day later this year. So I'm sure that we're going to be able to put this thing through its paces, see all of the cool things that it's capable of, and of course, ask the question that practitioners really want to have asked about these new products. I don't know if you know this or not, Stephen, but NVIDIA GTC, it's kind of a big deal. Futurum Group CEO Daniel Newman even referred to it as the Woodstock of AI. And given all of the news that we've seen recently about the valuations that NVIDIA has been getting, as well as how hot the AI market is, there's been a lot of questions about how people like Jensen Huang are going to be capitalizing on all of this excitement around AI and things. I think I figured out one of them, though, Stephen. That would be Blackwell, their newest architecture. The chip is named after American mathematician David Blackwell, and math is most definitely a strong suit of this particular product line. It has 208 billion transistors and powers a second-generation transformer architecture that accelerates inferencing. There's also support for fifth-generation NVLink and NVLink Switch connectivity to GPU clusters with speeds of up to 1.8 terabytes per second of bidirectional throughput, which means, if you want to do the math like our friend Blackwell, that could process the entire bandwidth of the whole internet with 11 chips. Blackwell is being integrated into new packages called the GB100 and the GB200, which stand for Grace Blackwell, which marry the Blackwell GPU with the Grace CPU. These superchips are very focused on tensor core performance and can be combined into new clusters of up to 72 Blackwell GPUs that have to be water cooled in order to be able to function properly. Okay, that's a lot of numbers, Stephen, and I would expect no difference from a chip named after a mathematician. What stands out to you about what Blackwell is capable of?
Well, there's a lot of things that stand out and still a lot of questions. I'm really looking forward to learning more from all the folks that are at GTC. We're also going to link to a note here, by the way, by Timothy Prickett Morgan, who is one of the greatest folks, one of the people that I rely on to help translate this stuff for me. I definitely recommend reading his coverage, as well as a lot of the coverage coming out of the Futurum group and other people who are there at the show. But so far, here's what we know. So Blackwell is the next generation GPU or AI processor, I say that importantly, from NVIDIA. Let's go through the product line a little bit. So there's the B100, which is a drop-in replacement for the H100. It's air-cooled. Basically, anything that was set up to use the previous generation, which was, by the way, of course, a great, the Hopper was a great platform for AI processing. You can just drop a B100 right in there, works great, improves performance, says to maybe about double performance, which is awesome. You've also got the B200, which is basically the ultra version of that, which marries two of these B100s together onto a single processor, and of course doubles performance there. We're looking at numbers anywhere from 3 to 6 to 30 times the performance of previous generations with the B200. Then there's the monsters, the water-cooled monsters. So there's the GB200, which is the Grace plus Blackwell. Now, back in the day, like yesterday, the GH was a Grace CPU with a Hopper GPU married together so that they could create basically a fully functional AI processing platform. Well, the GB200 is two of those GPUs with one of the Grace superchips, meaning that the Grace was underused generally, and now it's really being optimized in terms of power consumption and performance. And of course, with two of the next generation GPUs attached to it, the performance of this thing is just off the charts. Then there's the monster which is basically a rack scale GB200 system. They call it the NVL72 because it uses NVLink to combine 72 of these GB200s together. Well, actually, it's 36 GB200s because there's two per. Anyway, point is, we've got just an incredible rack scale system here, all connected with next generation NVLink to make it into basically a single rack that does, a data center's worth of AI processing. This thing is just incredible. What NVIDIA has been able to do by connecting these things together. Back in the day, we were excited that we were able to use NVLink to join together a few of these Grace Hopper nodes into a single processing unit. Well, guess what? Now you can have 72 of the next generation ones all within the same shared memory domain, all able to access anything and all able to act as basically one giant freaking GPU. I'm kind of speechless to see what NVIDIA has delivered here because this is unlike anything we've ever seen. And of course, it's got all the good stuff. We're talking HBM3 memory. We're talking, ultra high performance connectivity. Theoretically, you could even go beyond 72, but you're probably not going to do that because the networking costs, would really make that not probably worth the effort. But essentially, NVIDIA has done what they've always done, or what they've been doing at least for the last few years, which is delivering not just a next generation GPU, but an entire solution that delivers on incredible AI training and inferencing performance. One thing I'm going to call attention to, though, is not exactly clear what's inside the Blackwell processor. In fact, no one's entirely sure whether it even has CUDA anymore, which is why I'm hesitant to call it a GPU. So a few generations back, NVIDIA introduced Tensor cores. Well, Tensor cores are the ones that are doing most of the processing these days, not so much the GPU CUDA cores. And like I said, we don't even know if Blackwell has GPU CUDA cores anymore. I'm going to say that it probably does for backward compatibility, but going forward, I'm not sure we should really be calling these things GPUs anymore because they're just not the same monster. Now, Tom, I want to zoom in on one aspect here. Like I said, NVIDIA is optimizing this whole stack, and they're trying to make sure they spent a lot of time talking about how they ran simulations and looked at the ways in which their processors were being used in order to come up with not just a faster chip, but a faster system that combines all of these things interconnected. Interconnection is the story of the Blackwell generation, as I said, because we've got these, all these 72 nodes all linked together with NVLink. But one of the things that really stood out to me was Jensen Huang's comment that they've got 130 terabytes per second on the back of this chassis, which is more than the aggregate bandwidth of the internet. That is absolutely incredible, and it shows the promise of NVLink. NVLink seems to be outrunning PCIe, and that actually reminded me of a discussion we recently had with Jay Metz from the Ultra Ethernet Consortium, where he was talking about SerDes and how the Ethernet SerDes roadmap looks a lot nicer than the PCIe SerDes roadmap. And then you look at something like NVLink, which uses Ethernet style SerDes. Basically NVIDIA is delivering something today that is way beyond what we could do with PCIe. What does this mean for PCIe and CXL? I mean, you're the networking nerd. How does all this work?
Well, SerDes, for those of you who don't know, it's basically the serialization, deserialization interface. So SerDes is a lot like modem. It is a concatenation of those two things, a portmanteau, if you will. But the important thing to realize is that the way that the PCIe SerDes has been developed over the years is much different than the one that has been developed for Ethernet applications. So they're both doing serialization, deserialization of I/O, but one of them is much more strict than the other. And that has a massive impact on the way that everything works out. So PCIe 6 requires a bit error rate of less than 10 to the negative 12. Ethernet only requires 10 to the negative 4. Now, you're probably doing some math in your head trying to figure out exactly what that means. Here's what that means. every time you require a much stricter bit error rate value, you are basically creating overhead in the packet that would necessitate less data being sent for every packet that's going. Now, I'm sure that PCIe has a reason for doing this, because everybody has a reason for doing this. And when you think about the way that the interconnects work between what would normally use PCIe, which could be, the CPU and the GPU, or the CPU and the memory, or all these other things, they wanted to make sure that it was right. Ethernet, we don't care about it. It'll show up eventually. That's why we have TCP. But what that effectively means is that the limitations of what PCIe can deliver, even in current Gen 6, which is, 64 gigabits per second max. Okay. What did we say NVLink can do? 1.8 terabytes per second? That's a lot bigger, right? What they're basically saying is we have a high performance system right now that provides similar performance to what we would get out of a much stricter protocol. Now, in full disclosure, Ethernet style SerDes are a little more latency. They have a little bit more latency than a PCIe. Although I would challenge you that, 30 nanoseconds versus 100 nanoseconds, if you can figure that out, more power to you, because I can't. I can't even figure out 30 milliseconds versus 100 milliseconds. But what matters is that even though there's more latency, you're carrying much more data per transaction. And that means that NVLink will continue to grow higher than where, PCIe Gen 7, Gen 8 will be, in the next 5 to 10 years. I think what's really valuable to understand here is that NVIDIA is basically betting everything on NVLink, kind of like they've done with InfiniBand, where what they're trying to say is we have the most performant interconnect between GPUs, CPUs, and all of the clusters that we're going to be putting together. Why would you not use the fastest protocol that you have? Because when you look at the amount of data that's being moved back and forth, like they said on the keynote stage, this thing can move more than the aggregate bandwidth of the internet through the backplane of this chassis. Well, I would want it to go as fast as humanly possible. And based on the way that we have error resolution now, I'm not worried about, being ultra strict about forward error correction or things like that. So I'm applauding NVIDIA for basically backing their protocol, NVLink, right? But here's the thing that makes me kind of pause. This is how standards get created. No. I know you're probably sitting there thinking to yourself, no. Standards are created through the IEEE and the IETF, and there's a lot of arguing, and the loudest voice in the room wins. You're right. They do. Currently, the loudest voice in the world belongs to the third largest tech company in the world. That would be NVIDIA, who is developing a solution that makes everything run 3 times faster than the current standard. You know what's going to happen? Everybody's going to license that technology from NVIDIA, and they're going to start using it, and that becomes the de facto standard. Period. End of story. So I think that this kind of minutia breakdown of using PCIe SerDes versus Ethernet SerDes, really what it's going to develop into is more adoption of NVLink, more companies that are kind of at that inflection point going, well, if this is faster, we need to be using it instead. And then moving forward to embrace Ethernet style SerDes, which now I don't think PCIe is going away anytime soon. But I think what we may end up seeing is PCIe relaxing some of their requirements in future generations to accelerate their bandwidth and throughput so that they can compete with NVLink so that they don't get left behind in the dust.
Yeah. And I think that overall, that's going to be the interesting angle here. I want to come back to what I said. The most impressive thing to me about the whole GTC announcement this year is that NVIDIA is not talking about chips. NVIDIA, well, they are talking about chips, but what they're showing is systems. They're showing solutions. They're showing stacks. And really, that shows to me that this is a mature company who really understands their market. The fact that they're now delivering this incredible system that offers the NVL72 system that offers 720 petaflops of training and 1.4 exaflops of inferencing, admittedly in a 120 kilowatt rack or something crazy like that, but it is just off the charts. It's going to be really interesting to see how this thing scales down to smaller clusters that make more sense in the enterprise, as well as scaling up. I would love to see what a research system that can go beyond 72, because here's a hint, it can go beyond 72. I'd love to see what those things can do. And it really shows that NVIDIA is absolutely firing on all cylinders and that they really understand the market.
All right, Stephen, that was a great rundown of some of the cool stuff that is coming out of NVIDIA GTC this week, but we're already looking to the next weeks ahead because it is going to be a very full schedule coming up in April and May. I wanted to start off by telling everybody that we are going to be having our next security field day event April 10th and 11th, right after the big solar eclipse. You can check out some of the technologies that are eclipsing all of the security attackers out there from companies like Ariaka, Index Engines, Palo Alto Networks, and Zerto. Head over to techfieldday.com and you can see a link to all of the companies that are going to be presenting as well as the delegates. And then just a couple weeks after that, Stephen, you're back on deck with something really exciting.
Yep, that's right. We're returning to Edge Field Day. So May 1st and 2nd will be the next Edge Field Day event. We're going to be doing all things Edge and making a lot of announcements for that in the coming weeks.
And then after that, on May 15th and 16th, I'll be back with another edition of Mobility Field Day. This has been one of our flagship events in the enterprise wireless space. It's gotten a lot of conversation going on. We have some new delegate faces that will be joining us around the table for this event, and we are very excited to hear from some of our favorite friends at a lot of these enterprise wireless companies, including a couple of companies that may be getting acquired pretty soon. So, you might want to jump in and see this presentation and feel how it's going to work itself out. But if you want to learn more, of course, techfieldday.com is where you want to find all of that out. Stephen, right after that, though, there's something new coming up, isn't there?
That's right, Tom. We've got App Dev Field Day. So this is the first ever field day that focuses on modern applications, modern application platforms, application development. We're doing this in combination with the practice lead for App Dev over at Futurum Group, Paul Nashawati. And we're very excited to have our first sponsor signed up for this brand new field day topic. We're selecting delegates. It's going to be pretty cool to have a brand new field day event on the horizon. And then after that, I want to call out the fact that the biggest event of the year for Futurum is coming up, the 6.5 Summit. This is the annual summit where they bring together just an incredible panel of industry luminaries. It's June 11th through the 13th. You can go to the65summit.com to learn more about that. They've already announced that the keynote is none other than Bill McDermott, who is an incredible voice in the industry, somebody who's really inspiring and visionary, and is the CEO of ServiceNow.
Well, thank you very much to everyone out there in the audience for joining us for this episode of the Gestalt IT Rundown. Remember that we publish an episode every Wednesday on our YouTube channel, as well as through all of our other areas, such as our podcast feed and our show notes that we publish to the gestaltit.com website. If you want to check out the articles that we linked, as well as the ones that we mentioned that you're definitely going to want to dig into, because they have a lot of breakdown of some of the things that we have talked about here. We'll be back next Wednesday with more great news stories from, what happens through the rest of NVIDIA GTC, but also any other exciting things that come up in the tech industry. And if you have a story that you want us to cover, make sure you send it our way. You can find us on all of our social media properties. We're Gestalt IT. Until then, take care of yourself. Enjoy the fact that spring is finally here, unless you live in one of those weird parts of the country where it's just like fake winter this week and maybe spring after Easter. But until then, we'll be back with more great stories, and we will see you next week.